Welcome back to my session on data science. In my previous video, I explained about EDA and the steps involved. So the steps are like finding variable types, performing univariate analysis with continuous and categorical variable, performing bivariate analysis, treatment of missing values, and then treatment of outliers, and then the variable. In the forthcoming video, we are going to talk about variable transformation, feature sorting and merging, apply function, and aggregation. If you haven't watched my previous video, please go to my channel Data Chef and you will find it over there. Without any further delay, let's directly jump into the today's part of the video. So let me scroll down to the bottom where we are going to start with the variable transformation. Okay, it is there in the bottom, and I'm using the same telco churn data set which is available public, which is a public data set, and I'm going to use the same thing for today's video as well. So let me scroll down this. Yeah, okay, we have gone through all those things. Okay, yeah, here we go. Okay, so from my data set, I'm taking one variable called night minutes. Even though we have so many other features, I'm just taking the night minutes here. I'm going to put a plot, we're going to put the histogram for this night minutes. Once I execute this, I see like the most of the customer are there. They on an average, like they use about 150 to 250, and there are few customers between 50 and 100, and there are 250 and 300, but they are minimum. But what my most customers are doing, so in a month they use about 150 to 2 minutes as a night minutes call. So they talk about 150 to 200. Okay, so in variable transformation, sometimes what happens is we have to convert we have to transform this variable in a another form, like log form or square root form or cube root form, or it could be like any custom function also. So we are going to start with the square root transformation, for which I am using the NP. NP is nothing but my NumPy object, and I am saying power, and then I use the night minutes here, and night minutes as my variable, and this power 1 by 2 is nothing but my square root, and then I'm going to plot this. Look into this x-axis. Please pay attention on the x-axis. It is 50 to 300, but once I apply this, what I get here is 6 to 16. So whatever variable we had, whatever value we had, it has been transformed into a square root value. So that is what is the square root transformation. The another way to transform do the square root is, we in NP NumPy we have a built-in function called square root, sqrt, and we can directly use that as well. So if I do that, again I will get the same option here. But in case of my cube root, I don't have any cube root function over here in my NP, so that is the reason I have to use 1 by 3. So np.power df.night minutes and to the power 1 by 3, which means cube root. And once I convert the same thing, please pay attention on the square root value here. It is 6 to 16, but when I do a cube root, see how the values are getting changed. It is starting from 3 to 6.5. So this is a cube root transformation. And similarly, we can also use the log transformation, like I can say np.log night minutes, and then I can plot this. So I will get the log value of my night minutes. So this is how what you do is you transform the variable into one form to another form. So if you have it in a decimal format, so you can transform it to any format. And why do we do that? In some cases, if you want to have all the variables in the same scale, say for example you have a customer income ranging from say 1000 to 10,000, and then you have a customer calls which ranges between let's say 50 to 500. So in this case, in a machine learning always gives more importance to the higher number, higher weightage to the higher number. So to have the same scale and convert them into a same scale, so what we do, we transform this variable into a square root, cube root, or maybe we can log transformation, or any other domain specific function also. We can create our own function according to our domain knowledge, and then we can also make use of those functions to transform this variable. So this will definitely will give you when you are going to create a machine learning model. So once you transform this value to convert this value, this will give you a better performance in your machine learning algorithm. Okay, the another one, so whatever we have seen is here is a numerical value which is continuous. So here the another one is the another option is we can also convert this continuous values into a categorical value. But before doing that, let me take one example of day charge, which is the charges paid by the customer for making day calls. So in day calls we can see that we have about 1614 values here. And again, so I don't want this many values over here. I don't want 1614. I want to bin them into 3 buckets. So what I can do is and before that even let me plot this and show you. Like day charge, again you have a plot box and you have a range between these are the day charges, that is each customer paid, and this the total count is 1614. So let me the total unique values. So what I want to do here is I want to bin them into a low category charge, a medium charge and high charge. So the customer who pay less, we categorize them as a low category customer, and where the customer who uses between this number to another number, we categorize them into a medium category, and the customer who uses more, who pays more, we categorize them as a high value customer. So this is just an example, but again according to your domain you can make use of any other groups. So I'm creating a new variable type here called customer type, which is not exist in our data frame, and I'm using a pandas cut function here. So the pandas cut function, what I'm saying is binning. I'm saying 0, 20, 40 and 60, and I'm saying 0 to 20 is my, when the customer is paying between $0 to $20, I'm categorizing that customer as low category, and when the customer is paying between 20 and 40, I'm saying the medium, and 40 and 60 I'm calling it as a high. So the high value customer type. So all I need to do is df custom is a new variable that I'm creating, and the cut function I'm using here, and then the bin is nothing but which I declare here, and the group which I declare here. So once you execute this, so what you get is, see, you have to get the value count. Again, value count will give you the customer falling under each category. So now you can see you have 3 values here: medium, high and low, and you can see there are about 2335 customer falling in medium category. So they are medium category customer, and there are about 464 high value customer and 412 are low value customer. So this is how you can create a new variable also, and what you learned here is 2 things. One is binning and another one is deriving a new value or new feature out of the existing feature. There are several other ways through which you can derive your own features, but again it requires specific domain knowledge, and once you have the domain knowledge you can derive more and more. So let's move on to this, and let's see, I put the df.info, which again gives me the column information, and let me scroll down, and you can see here I have a customer type, and which is again a categorical variable which is created. Till now we had only 21. Now I have another one called, sorry about it. So the another one is the customer type. So then let's move on to the other functionality called sorting and merging. So we can sort the values. Sorting is not again, but is sorting in a descending order or ascending order. So what I'm trying to do here is I'm sorting this entire data frame by account length. Account length is again nothing but the tenure of the customer. The tenure of the customer, and I'm saying ascending equal to false, which means sort my data frame based on account length and in a descending order. And when I say in place equal to true, it will automatically update my data frame. If I don't put that, this will not be updated in my data frame. So, and then when I say df.add, you can see that the account length is sorted in a, so 243 is the first customer, and then you see 232 as a second, 225 again, and then you see 224. So you can see this is sorted in a descending order. So this is one simple command that will help you to sort your the sort values is the one simple command which will help you to sort your data frame in a ascending or descending order. You can also do the sorting based on two columns. You can take this sort value by account length and day charge. So instead of one column, what I'm doing here is I'm providing two columns here or two features here. I want first this to be get sorted by account length and by the day charge. So you don't see any difference here, but look at this customer 225 and 225, these two customer. So you can see here it is sorted, day charge is sorted based on, so 31.06 coming first and then 28.12 is the next one. So this is sorted based on the two columns. Then there is another beautiful function called apply. So why do we need apply? So if you want to, let's say you want to apply you want to do some process column wise or row wise, you want to perform some task, and so the one option what we do in any language like C, C++ is we iterate through all the rows and then we update one by one. So instead of rather doing that, what we do here is we have a beautiful function called apply, which will help us to avoid for loop and while loop. So and it is also faster than your for and while. So apply function used to perform data pre-processing and data manipulation task on both row and column wise, and it is faster than your while loop, for loop or while loop, and it is widely used in a feature engineering code. So whenever you work on the feature engineering, deriving a new feature or transforming a feature or handling a missing value or outlier treatment, or you do any improvement on your feature, that is called feature engineering. So what I am doing here is I am creating one function here, and this is how you create a function in Python. You say definition, and then I am creating a caller type, caller underscore type, and I am passing a parameter called num. So what I am doing here is when num is less than 1, I am saying he is a happy customer. If num is greater than 1 and less than 3, I am saying the customer is okay customer. So okay, it is okay, no gain, no loss for this customer. And when the number of calls, what I am going to use is when the calls are more than 3, other than greater than 3, I am going to say unhappy customer. When I say call, here I am saying the call that was made by customer to our customer care. So that is what I am calling here as a caller type. So happy customer, okay customer, and unhappy customer. And what I am trying to do here is I created another variable called customer condition, or we can also call it as a customer sentiment, and then I am applying the apply function here, df.apply, and then using a lambda function and saying I am calling the function which I defined over here, and then I am saying I am passing the value here, the column name for which I want to make a apply this function, and this is as a column wise, so I have to say access equal to 1. So once I do this, what happens is you can see here on my right side, customer condition, there is a new feature created called cust condition, and it says that okay, this customer is a okay customer and this customer is a happy customer. Similarly, we can also know that whether if the customer is a unhappy customer or not. So by just looking into the customer service call, this column, we can define a new feature, and what we have done is we have made use of this beautiful function called apply, and we created a new variable called customer condition. So this is one way of doing it. And once you do this, somebody is asking like, okay, tell me how many happy customer you have, or how many unhappy customer you have. Now you have the option, you just go to the new variable called cust condition, df.custCondition, and then say value count, and what you get is you can easily say we have around 1871 okay customer and we have around 673 unhappy customer. So this is how like you can create a new feature and derive a new insight out of the existing feature. So remember the raw data that what is given to you, if you directly put that into a model, you may or may not get a very good insight, until otherwise you do some kind of a feature engineering task on top of it. So this is one kind of a task, like we are deriving a new feature, and we are now we can easily answer our business saying that okay we have. But again, the count doesn't make any sense to me, because to the business I cannot go and tell the count. So what business may be interested more on the percentage. So the same function value count, and within the value count, when you say normalize equal to true, then what you get here is the percentage. Now I can go and say that we have around 21 percentage, 20.9, roughly around 21% of customer who are unhappy with us because they have made more than 3 calls in a month. Okay, so then, okay, this is one way of apply function. We have another one, the fancy one called progress apply. Again, this is a part of your TQDM library. The TQDM library will help you to get the progress. The only difference what you see is you get a progress bar. So in our case, we have around only 3,333 customers, so it is okay to go with apply function. But assume that you have 1 million rows, and once you apply it, you may not know that what is the completion percentage. And for each completion, if you want to know the progress, like how much percentage is completed, you can call this df.progress apply, and then you can do the same thing what you have done with the apply function. So, and you can call your custom function here, and then you will say that you get this kind of a nice progress bar, and this will give you the this will give you the progress bar with the percentage. Moving on to the next topic called data aggregation. So we cannot just get insight with the raw data. Remember, we already talked about raw data. Just take the raw data and you put that into a model like logistic regression, random forest, or XGBoost. No matter what you do, like sometimes you may not get a very good insight. So what you have to do is you need to aggregate this data. So once you aggregate this data, and then you perform your any machine learning algorithm on top of it, you may get a better result. So to do that, what we have is we have a group by function, crosstalk function, and pivot table. Remember, aggregation is not only for machine learning. Even if you are creating some reports and you want to present that report to your business without even creating a model, you can easily get those information using the data aggregation. So let's go on to this. So what I'm trying to do here is we have created a customer condition, right? The sentiment. So I'm just grouping it by condition, and then I'm saying I'm print the first few rows. So what it says that, okay, this is like this is now you can see here the customer condition is here, and it says that it is grouped by the happy customer, okay customer, and unhappy customer. But is this very insightful? I don't think it is very insightful, because it is not giving me any meaningful information. So we just grouped it, but we haven't applied any function like average or sum or median or anything. So once you do this, you get a new data frame called bycast. In my case, I created as a bycast. So I get this, and then what I do is I apply a mean on top of it. So I just say bycast customer service call mean. I want to know for like what is the average call made by the happy customer, okay customer, and unhappy customer. So you can easily see here the happy customer didn't make any calls, which is 0.0, and then you can say that okay customer is 1.3%, sorry, yeah, 1.3, and then you can see that unhappy is around 3.6 calls per month. So this is how you can get the insight from your data set. So similarly, I have given the median also. So mean is the one function, median also. So median says 0, 1, and 3 for all the 3 categories. And then the one is, this is with the, we have done it with the one variable, right? So we can go ahead and we can do the same thing with the more than one variable. So that is called grouping the feature by multiple columns. So grouping by multiple columns or multiple features. So group multi-columns is my data frame that I am creating, and I am saying group by state and the condition. And then I am printing the here, you can see you have a state here, you have a condition here. So let's again apply our average function and other things and see like how the data set looks like. So I am saying group multi-calls, customer service call. I wanted to see by state how it is looking like. So for AK, the state, this again remember this is a US state. So for AK, the happy customer, it is around 0. It is a 0 calls made by the happy customer. For OK customer, it is 1.3 calls per month, and for unhappy customer, we can see there is 3.3. Similar way for let's take this example, AR. For AR, the unhappy customer made around 4 calls per month. So what it means? So this way we know that rather than looking into the entire data set and saying that okay, these customers are unhappy, we can derive more insight based by the state. So that's how the grouping condition and everything will help you out. So you can see here AR, the state AR, maybe Arizona, so where the customers are very unhappy and they are making around 4 calls per month. And then you can see that CA, California, where they are making around, on an average they are making 4.5 calls per month. So you can say that rather than focusing on AK first, you can go ahead and straightly you can focus on California customer and see if they have any problem in the connectivity or network, or maybe anything related with their bills, or maybe any service related problem, and you can go and you can get more insight out of it, and you can provide solution to them. So this is how this grouping or aggregation will help us out. Okay, and then I apply the sum function here. So sum also tells me that okay, the unhappy customer made around 40 calls, and here the unhappy customer made around 63 calls. So again, that was the mean, and this is the sum. Then the other one what we are going to see here is a total charge. Till now we had a charges like day charge, evening charge, and night charge as a separate feature. I'm going to add up, sum up everything and creating a new column called total charge. So it is very easy. Just take all the feature and say plus symbol. So you get, and you can apply any mathematical calculation also here, and you can get the total charge. So, and then you have the total charge. So this is how you create this is another way to create a new variable or feature. And then we are going to learn about the pivot table. Pivot table is nothing but, if you are already familiar with Excel, it is nothing but the pivot table, the same pivot table what you have seen in Excel. That is what pivot table in Python as well. So you have a customer condition, and I want to pivot it by customer condition, and I want to value is the total charge. So I can say that the total charge paid by. So my hypothesis here is whether the total charge is the one reason why is there any difference between the total charge that is paid by the happy customer or okay customer and unhappy customer. Is this the charge that is making them to unhappy? So to prove that, we can take this and we can do the pivot. And what I see here is my hypothesis turned out to be is an alternate hypothesis, because I thought like the charges could be if the charges are high, the customers are unhappy. But when I'm looking into the data, see the data, it is around 56 only. So even you can see that happy customer is paid about 56.6, whereas the unhappy customer only 56.4. So my hypothesis turned out to be a alternate hypothesis. So it is not the charge that is making the bill that is making the customer unhappy. So you can also do the pivot table with the more functions, like you can with more column. In this case, I am taking area code, customer condition, and churn. Churn is again my target variable, and the total charge is my value that which I created in my previous step. And I don't want just to go with the mean or anything. I want multiple. I want to create new functions, like new features with the np.mean. Np. is again average, median, min, max, and the standard deviation. So once I run this, what I get is this is what it looks like. Like I grouped it by area code, so it is here. Grouped it by customer condition, then grouped it by customer condition, it is here, and then group it by churn. So you can see here from the area code 408, let us take the condition for unhappy customer. So it is saying that okay, the customer who did not churn, the average bill is 56.3, and the customer who who churned out, they paid slightly lesser than the customer who did not churn out. So again, this again proves me that there is no evidence that says that the bill is the one of the reason for the customer to getting churned out. So what we can do is, this could be another reason. The customer may be unhappy because of other service related issues, or it could be like a network issues, or it could be like the customer might have got some offer, better offer from our competitor. So if the competitor is paid given some better offer, there are high chances that the customer will move from our service to the competitor services. So those are some of the things we have to understand whenever we are doing analysis. So just taking the data set and dropping into the model and running the deep learning or machine learning will not give you any inferences. So you have to do the EDA, and only when you do the EDA properly, so you will get the good insight out of the data set. So even even without, in some cases, to handle the low hanging fruit, to get the insight out of the low hanging fruits, you can make use of EDA and you can get a very good insights out of it. So with this, we come to the EDA session part 2. If you like my video, please do share it with your friends, and if you have any suggestions or for improvement, please do let me know. I will be happy to take your comments and I'll work on it. Thank you. See you again in the another video.